Hi, welcome back friends. Today we are going to discuss the problem 101 of LeetCode symmetric tree. Before we start discussing this problem, I just want to mention that I often create videos regarding LeetCode solutions and Java J2E interview questions answers. So if you are interested in this, please subscribe to my channel. It helps the channel to grow and reach to more people. So let's go back to the problem. Given the root of a binary tree, check whether it is a mirror of itself, that is symmetric around its center. So as you can see, they have given this one example here. So if you draw a line from root like this, and if you see, it is like a mirror image, right? So 2 2, then like a 3 will be 3 here and 4 is 4 here, so it is kind of a mirror image. This subtree is a mirror image here for itself. So let's take one example here, or we will see and discuss how we can implement this. So as you can see, we will be like writing a recursive function where we can pass like two nodes we will pass. For example, we will pass roots left node here too, and roots child node here in the start, in the like roots right node in the start to the function. So left node and right node, and then we will compare like both nodes. If both nodes are equal in value, we will first check like if they are null, or they are like one is null, other is not null, those cases. And then if both nulls are present, then we will check if they are equal in values. Then what we will do is we will again call the same function recursively, where we pass this left children first to this function, and at the same time we will pass this right child's right node to that function, right? So and uh, we will call it two times, right? The left nodes right child, so this one, and right nodes left child. So these two values we will again pass to the recursive function. So it will compare again 3 is equal to 3 and this 4 is equal to 4. Then again we will recursively call this function. Now we will take this 3, this node, and we will call its left child. We will take this 3 node and we will call its right child. So we will, if it is left, then this is right, and here we will call uh, here, then we will call the right child of 3 here, pass this value, and we will call left child of 3, which is 6 here, we will pass this value. So as you can see, 5 is equal to 5 and 6 is equal to 6. Now we have these two nodes again to compare. So what we will do is we will take this node, we will pass its left child to the function, and we will pass this force right child to the function, and we will pass right child of this node, which is 8, and left child of this node, which is 8. So as you can see, always 7 and 7 matches, 8 and 8 matches. So since at the end everything match, then it will return true as a symmetric tree. So this is the implementation. So we will just first check if root is null, then we will just return that false, it's not a symmetric tree. Otherwise we will call is symmetric recur. So this is the function we have implemented, where we will pass a left node and we will pass a right node. So what we will first check is if the left node and right node, if both are null, then it is true, right? Means both are null means it is true, we will return. For example, here if we pass null here, this is null, right? And then we will pass, let's say this 5's right child is null, then this is true, that's what it will say. Then we will check if one node is null but other node is not null, basically in this past function, right? Then it is false, obviously. For example, if this 5 is not there, then here we will pass 5 and here you will get null to compare, right? Then in that case you will return false, because that cannot be a symmetric tree. Then when we reach here, we already know that we have a left and right child, left and right nodes present, so we will compare their values. So if the values they do not match with each other, then we will return false. For example, if let's say instead of this 2, if you have 4 here, then you will not, this 2 and 4 will not match, so you will return false in that case, right? So that's what it will do. And if the values matched, for example, if this 2 is equal to 2 match, then we still want a way to go, right? Because we still have a nodes to traverse, so we will pass this 2's left child and 2's this 2's right child. So that's what we are doing here. So we will take left's left and right's right, and then we will take left's right and right's left, and we will recursively call these two functions again, because we want to visit every node and we want to make sure that this whole subtree, this whole subtree is symmetrical to this whole subtree, right? This whole subtree, if you draw it like this. So we have to visit each and every node, and we want to make sure that the complete subtree is matching the other complete subtree. So means matching in the sense symmetric, right? So that's how we are going to implement this recursively. So this is how we can recursively implement symmetric tree. So I took the first example as it is given, and I took this bigger example that we created here. So let's just run our code quickly. So it is accepted and both are true, so both are symmetric. So let's take one more example where we will just make sure that negative test case is there. So instead of this last 5, we will just make it 15, right? So instead of this last 5, this we are going to change this 5 to 15 and make sure that now it is not symmetric, so it should return false. So as you can see here, the third one, right, it is false now, so it is working fine. So let's submit this code. So the solution is accepted. So this is how we can solve symmetric tree using a recursive function. So as I mentioned earlier, I often create LeetCode problem solutions and the Java J2EE interview materials, as well as how to approach interviews. So if you are interested in this, please subscribe to my channel. If you like this solution, please subscribe to the channel and click on the like button. Also hit the bell icon so you won't miss any future videos. Thanks for watching.